Hi children, welcome to maths classes. Children, today let's discuss the topic operations on real numbers. What are real numbers, children? Real numbers include rational and irrational numbers. Rational and irrational numbers together are called as real numbers. Children, we all know that rational numbers are closed with respect to addition, subtraction, multiplication and division. What is this, children? Rational numbers are closed. That means you know the closure property, right? When you add two rational numbers, let's take some examples. 1 by 2 and 1 by 4. When you add two rational numbers, what do you get? 1 by 2 plus 1 by 4 is 3 by 4. So again you got a rational number. Suppose when you subtract two rational numbers, 1 by 2 minus 1 by 4 is equal to 1 by 4. If you subtract also, you got a rational number. When you multiply two rational numbers, what is 1 by 2 into 1 by 4? It is 1 by 8. What did you get again, children? You got another rational number, 1 by 2 into 1 by 2. You got 1 by 4. Let's do division of two rational numbers. 1 by 2, 2 by 1 by 2. You got 1. 1 is nothing but 1 by 1. That means you got a rational number again. That means when you add or when you subtract two rational numbers, you are getting rational number again. When you are multiplying rational number, you are getting rational number again. When you are dividing two rational numbers, you are getting a rational number again. If you perform operations on rational numbers and again if you get a rational number, that is called as closure property. So, rational numbers are closed with respect to addition, subtraction, multiplication and division. Now, let's see how irrational numbers are there. What will happen when you multiply a rational number and an irrational number? What will happen when you add rational and irrational numbers? Let us check what will happen when a rational number and an irrational number are added, or when a rational number and irrational number are subtracted, or when we multiply a rational and irrational number, or when we divide a rational and irrational number. Let's check if closure property is satisfied or not. That is, if we add rational and irrational number, let's see we get irrational or rational numbers. Let's do this with some examples. Let us consider this example, children. 7 into root 5. 7 into root 5. That means we are multiplying a rational number 7 and an irrational number root 5. 7 into, what is the value of root 5, children? It is 2.236 and so on. So, when you multiply, what do you get, children? 7 6 42, 7 3 is 21, 25, 7 2 is 14, 15 16, 7 2 is 14, 15 and so on. So, when you multiply a rational number and an irrational number, again you are getting an irrational number. Let's take another example. 7 by root 5. How do you solve this, children? We can solve this easily by rationalizing the denominator. Rationalizing the denominator means here in the denominator you have a rational number. So this denominator should be converted into a rational number. How do you do that? 7 by root 5. Multiply both numerator and denominator by root 5. So, 7 into root 5, you got 7 into root 5 in the numerator and the denominator, root 5 into root 5 is nothing but 5. So, in this way, we rationalize the denominator to solve the problem easily. 7 by 5 into root 5. What do you get? 7 into 2.236 by 5. 2.236 and so on. 5 ones 5, 20. 5 fours 20. 1.4 into 2.236. If you multiply again 2.236 and so on, it continues. So again you get an irrational number. So when you divided 7 by root 5, you got a irrational number again. Root 2 plus 21. What is the value of root 2, children? 1.414 and so on plus 21. If you add a rational and an irrational number, you get what? 21 plus 1.414 is 22.414 and so on. So let's do pi minus 2. What is pi? 3.1415 and so on. Minus 2, what do you get? 1.1415 and so on. So again, you got irrational number. So children, from this we came to understand that when you add a rational and irrational number, when you add a rational and irrational number, when you subtract a rational and irrational number, pi minus 2, pi is irrational, 2 is rational. So when you subtract a rational and irrational number, or when you multiply a rational and irrational number, 7 into root 5, 7 is rational, root 5 is irrational. When you multiply a rational and irrational number, or when you divide, 7 is rational, root 5 is irrational. When you divide rational and irrational number, when you add, subtract, multiply, divide a rational and irrational number, what did you get, children? You got a irrational number. From this example, you can conclude this, children. When you do this following 4 operations on rational and irrational numbers, you get an irrational number. Children, now let us see what will happen when we do operations on 2 irrational numbers. From these examples, example 13, add 2 root 2 plus 5 root 3 and root 2 minus 3 root 3. These are irrational numbers. Let us see what will happen when we add them. 2 root 2 plus 5 root 3 plus root 2 minus 3 root 3. See children, in 5 root 3 and 3 root 3 you have root 3. So let us write them first. 5 root 3 minus 3 root 3. Next 2 root 2 root 2. These two have root 2. Let us write these two at one place. Plus root 2. Now take root 3 common. Root 3 of 5 minus 3 root 3. Root 3 as common, so you get minus 3. Plus from these two, take root 2 as common. 2 plus 1. So 5 minus 3 is 2. 2 root 3 plus 3 root 2. What did you get, children? When you added 2 irrational numbers, you got irrational number again. You got irrational number again. Now let's do example 14. Multiply 6 root 5 by 2 root 5. Multiply 6 root 5 by 2 root 5. 6 into 2 is 12. Root 5 into root 5 is 5. 12 5 is 60. You got what, children? You got a rational number. So when you multiply two irrational numbers, 6 root 5 and 2 root 5, 6 root 5 and 2 root 5, got 16, got a rational number. Let us take other rational numbers. Root 3 into root 2. What do you get, children? Root A into root B, you can write as root A into B. You got root 6. Here you got what? Irrational number. So in this case, when you multiply two irrational numbers, you got a rational number. In this case, when you multiply two irrational numbers, you got an irrational number. So at sometimes you get a rational number, sometimes you get a irrational number. What will happen when you divide 8 root 15 by 2 root 3? 8 root 15 by 2 root 3. 2 4s 8. 4 into root A by root B. You can write as root A by B. That means root of 15 by 3. 3 5 is 15. So you got 4 root 5. What happened, children? Here when you divided a irrational number by another irrational number, you got an irrational number here. Let's take another example. Let's do root 2. Root 2 is an irrational number. Divide it by root 2 itself. What do you get? You get 1. 1 is a rational number. So, sometimes when you multiply two irrational number, you can get a rational or a irrational number. When you divide two irrational numbers also, you can get a rational or an irrational number. When you add two irrational numbers, you got an irrational number here. Similarly, what will happen when you subtract two irrational numbers? Root 2 minus root 2. You will get 0. This is a rational number. Root 2 minus 3 root 2. What do you get, children? Root 2 minus 3 root 2 is minus 2 root 2. It is an irrational number. So, subtraction also, when you subtract two irrational numbers, you may get either a rational number or an irrational number. In addition also, here you got irrational number, children. Let's do root 3 plus minus root 3. What do you get, children? You are adding two irrational numbers. One is a positive irrational number, another is a negative irrational. You will get 0. That means you got a rational number. So children, you can conclude that when you are doing operations such as addition, subtraction, multiplication and division on irrational numbers, you can either get a rational number or you can get an irrational number. From these examples, you can observe this, children. Children, in our previous videos, we learned how to represent root x on a number line. That is, if we want to represent root 3 on the number line, we first represent root 2. If you want to represent root 5, we'll start with root 2, then root 3, then root 4, then root 5. In this way, we used to represent. We saw this in previous videos. Children, there is another way to represent root x on the number line. Root x, suppose root 3.5. How can we represent this on the number line? The procedure is this, children. X is any real number. So, first draw a line of x unit. AB is of x units. Then, extend this point B. Draw BC of length 1 unit. AB is of length x units, BC is of length 1 unit. Now, what is AC, children? AC is x plus 1 units. Now, mark a center point O. Then OA will be x plus 1 by 2. Mark the midpoint of AC. Midpoint of AC will be O and OA is equal to x plus 1 unit. Similarly, OC is equal to x plus 1. This is O is the midpoint of AC. That means OA will be x plus 1 by 2. Similarly, OC will be x plus 1 by 2. Now, with center at O, measure OA and draw a semicircle with radius OA. With radius OA. With radius OA. What is this x, children? X is AB. AB is of length x units. Now, with radius OA, draw a semicircle. Draw a semicircle. Semicircle you will get in this way because OA is equal to OC. Now, after drawing the semicircle with radius OA, here x units is what? A, B is x units. First step is draw a line. If you want to represent root x on the number line, draw AB of length x units. Then extend B, that is extend B to C where BC is 1 unit. Now first step is AB is AB is x units. Then BC is 1 unit. This is second step. Then so AC will be what, children? If AB is x units and BC is 1 unit, AC you get as x plus 1. AC you get as x plus 1. This is third step. Then OA. OA means mark O. What is O? O is the midpoint of AC. O is the midpoint of AC. Mark this point. O as the midpoint of AC. This is fourth step. Then you get what? OA and OC. OA is nothing but sum of this AC by 2. AC is x plus 1. OA is equal to OC, that is equal to x plus 1. This is fifth step. Now at B, draw a perpendicular to this semicircle. At B, draw a perpendicular. This will be root x. So, simple 5 steps, you will get root x, children. Now if you draw a perpendicular at B, you get root x. If you represent this on the number line, how do you represent? Keep your compass on B, then measure this point P. Let it be P on the semicircle. With this PP, you can measure and draw on the number line. You can get root x here somewhere. So these are the steps, children. Let's see how BP will be root x. Children, BP is the perpendicular line. So OBP will become a right angle triangle. Here AB is equal to x units and OA is equal to OC is equal to x plus 1 by 2. Now what is OB, children? OA is x plus 1 by 2. What do you get OB? OB is nothing but AB is x. OB is AB minus AB. This is AB. AB length you know already. Minus OA. AB minus OA you get as OB. AB is x units you got here. AB is x minus x plus 1 by 2. Take LCM as 2. 2x minus x minus 1. You got x minus 1 by 2. Now you got OB as x minus 1 by 2. See, OB is x minus 1 by 2 now. You know Pythagoras theorem, children. Apply Pythagoras theorem to triangle OBP. Hypotenuse square OP square is equal to OB square plus BP square. What is OP, children? OP, this is a semicircle. That means OP is the radius. OA is also radius. Similarly, OP is the radius. So, length of OP will be same as OA. You will get x minus 1 by 2. OA is x plus 1 by 2. So, OP will also be x plus 1 by 2 whole square is equal to OB square. OB is what? You got OB as x minus 1 by 2. X minus 1 by 2 whole square plus BP square. So children, now see here children, BP square is equal to x plus 1 by 2 whole square minus, what do you get? This will go to LHS part, minus x minus 1 by 2 whole square. Let's solve this, children. This x plus 1 by 2 whole square minus x minus 1 by 2 whole square by 2 square means 4. Here also 4. You get 4 as LCM. What is x plus 1 by x plus 1 whole square? X square plus 1 plus 2x minus x minus 1 whole square, x square minus 2x plus 1 by 4. X square minus x square will get cancelled, plus 2x plus you will get 4x plus 1 minus 1, 4x by 4. You got x. What? BP square. BP square is equal to x. So you got BP as root x. So we are able to prove this. We are able to prove that BP is equal to root x. So children, to represent root x on the number line, first draw AB of length x units. Then extend it. Then extend AB to 1 unit again. BC as 1 unit. Then measure AC and mark midpoint as O. Then with radius OA, draw a semicircle. Then draw a perpendicular at B. Mark it as P on the semicircle. This BP will be root x. You can take a compass and measure BP, and with this BP length, you can mark it on the number line. In this way, root x can be marked on the number line. Root 3.5. Suppose if we want to mark root 3.5 on the number line, first mark AB as 3.5. Draw length AB as 3.5 units. Then extend BC. It will be 1 unit again. So completely AC will be 3.5 plus 1 4.5. So here AB, first step AB, draw a length AB of, if we want to mark root 3.5, draw AB of length 3.5 units, first step. Then draw BC of length 1 unit. So now completely AC will be what, children? 3.5 plus 1 is 4.5. Now mark O. O will be what? Midpoint. So midpoint of AC. What is midpoint of AC? AC by 2. That means 2.25. So OA is equal to OC is equal to 2.25. Mark this point O. Then this will be 2.25. This will be 2.25. Then draw a semicircle with length 2.25 units. Draw a semicircle with length 2.25 units. Then draw a perpendicular at B. Draw a perpendicular at B. You will get root x as 3.5 units. BP will be length 3.5, root 3.5 units. Then take a compass and with this BP length you mark on the number line. You can now locate root x, that is root 3.5 on the number line. This is another method to locate a real number, that is an irrational number on the number line.
Thank you for watching the video. Like, comment, share and subscribe.